This chapter covers valuing common stock and preferred stock. So the first formula I'm going to do is our preferred stock valuation, and that is called a zero growth formula. And the reason it's zero growth is because preferred stocks will pay a set dividend, and they will always pay that dividend throughout their lives. So if it could be a percentage of the par value, or it could just be a set dollar amount. So for this first example, it's one that pays a percentage. So it is a par value of $100 with a 10% annual dividend. So then that obviously is going to be a $10 dividend each year. So what it asks is that if the current market value is 8%, what would be the value of that preferred stock? So we're going to take that $10 dividend and then divide that by our required rate of return. So in this case, the first scenario, the required rate of return would be 8%. So then now we take our $10 and divide that by 8%, and that gives us $125 per share. Okay, then it asks, well, what if the rates change? What if our required rate goes up, and then now it goes up to 12%? What will that do to the stock price? Oops. So then now we take that same $10 dividend and we divide it by 12%, and that gives us $83.33 a share. And then you got to kind of get the big picture. I mean, that's the mathematical formula for doing it. But if you want to think about it a little bit, this preferred stock is paying a 10% dividend. If in the market all the other preferred stocks that you can invest in are paying 8%, then this stock is going to be in demand. It's paying a higher dividend each year. So then people are willing to pay more to get it. So it pushes that stock price up. If the market goes the other direction and the other preferred stocks in the market are paying 12% and this one's only paying 10, then no one's going to want to invest in that one. The price is going to have to go down to bring a market. So it brings it down to $83.33 a share. So you're going to want to be able to, first of all, compute the dividend and then calculate out that estimated price depending on what the required rate of return is at that time. And again, that is our zero growth formula. Now then we'll also have a constant growth rate formula, and then that is used when we value common stock, because for the most part, at least in this particular textbook and with the problems that we do, we're assuming that the dividends are increasing at a constant rate each year. So then that will be our next computation. So then our constant growth rate formula, again, it's going to be for common stock. The zero growth was for preferred stock. And if we have a scenario where a stock is expected to pay or has paid a 50-cent dividend, and it's expected that it's going to grow at a constant rate of 7% each year, and the required return is 12%, what would we expect that stock price to be? So the current dividend is not the expected dividend. So our current dividend is the one that just got paid, it's 50 cents. The formula is going to call for our expected dividend divided by that required rate minus our growth rate. So that's actually the formula. So if the past dividend, the one that was just paid, was 50 cents, and the problem tells us that we expect it to grow at 7% each year, our expected dividend is going to be 7% more than that 50 cents. So if we take the 50 cents and we multiply it by 107%, that's the quickest way to do it. You could multiply it by 7% and then add that back to 50 cents and you'd still get that same answer. But if you want to just do it in one step, multiply it by 107%, so that gives me 53.5 cents. So that's my expected dividend. So I would put that into the formula here. My required rate for this one is 12%, but then how we're gonna achieve that 12%, part of it's gonna come into play with that growth rate, that 7%. So then that's why we subtract it out. So then basically you've got 53.5 cents divided by 5%. And that gives us $10.70. So that would be the price we'd be willing to pay for this particular share of stock if it was growing at 7% and we required a 7%, or I'm sorry, a 12% return. So then just don't forget that you may have to recalculate. They may give you the past dividend and you have to add the growth to it. And then there's going to be some formulas that, or some problems that you have to calculate this growth rate. So if you, and normally how you do that is if you have a dividend history, if you have, so let's say we've got from 2018 to 2014 dividend history, and this will just be a whole separate one. So say if it starts at 75 cents, then it goes up to 78 cents, then it goes up to 82 cents, then it goes up to 85, and then it ends up at 89 cents. So we can see it's growing, but what we want to know is what percentage is that growth? You know, it seems to be a few cents every year. So we can go to our time value of money keys and calculate what that growth rate is. Now the key to these ones is don't just look at your number of years. Don't just look here and say, okay, I got 5 years, so my N is 5. It's your difference between the years, so then it's actually 4. And the easiest way to figure that is just subtract the years. 2018 minus 2014, it's a 4-year difference. And then we're computing our IY. The present value is going to be the dividend that was the furthest down in time, so it's 0.75. Our payment is 0, and our future value is 89 cents. And then now we'll put those into our calculator. So again, our N is 4. The present value will make it negative 0.75, and then push the IY button, push your PV button, 0 out that payment. 89 cents is your future value, and then come back and compute the IY. So that gives us 4.37%. So we'd have a 4.37% growth rate. So then you may have problems where, again, the growth rate isn't given and you need to solve it. So if that's the case, you'll have a history of dividends and then you'll be able to put those into your time value of money keys. And then you can go back and put that into your constant growth rate formula. So those are the 2 ways that we'll calculate our preferred stock using the 0 growth, and then common stock using the constant growth rate.